The other idea I wanted to focus on is we actually know, besides what we've learned here, what we've learned here is that a z-score of 0 means you did how? Average. The higher the z-score, the better off you are. And I think there might be a few example homework problems where you're asked to compute things. Let me see what I wrote down here. We didn't. That's okay. Let's look in our books for just a minute. No, I think I can actually say this to you as well. If you turn to page, looks like 146, 147. Let's actually use this problem with a couple more things here. If I score, actually we can start it off very easily. If I score at the mean, what z-score did we say that is?
0.
You get a z-score of 0. If you get a z-score of 0 and I say, what percentage of the class did better than you? Which you may want to write down. If I get a z-score of 0 and I say, what percentage of the class did better than you? What would be your answer? You got a z-score of 0. Z-score of 0 means you did average. So what percent of the class did better than you?
50.
50%. What percent of the class did worse than you? 50. There's a place you can look that will actually tell you that. So the z-score of 0, if you get a z-score of 0 and somebody says, what percent did better than you? You say 50%. What percent did worse? You say 50 again. We know some other things about these +1 and +2 values, and I'm going to share these with you just so you know them, and there'll be some building off of that. If you get a z-score of 1, we had a z-score of 1 in these examples, didn't we? But if you get a z-score, if your z-score is 1, what percentage of the class did better than you then? More than 50 or less than 50%? If you get a z-score of +1, did more than 50% do better than you or less than 50%?
Less than.
Less than 50%. So if you get a z-score of 1, if you look at these charts on 146 and 147, they actually show you some charts and some percentages here, and we actually know a couple of these. I'm trying to find my right one. Actually, I may want to just write this up on the board. There's one thing I can draw. That's about it. If the z-score there is 0, what percent of the curve is out this way? We just said before. 50%. If you get a z-score of 1, you actually know a z-score of 1, there's about 16% out here. If you get a z-score of 1, about 16% of the group did better than you. I'll show you where we get that number, but that's something just good to know. About 16% did better than you. How about -1? Get a z-score of -1. If I told you on a test that I took a physics test and I got a z-score of -1 and I said, what percent of the class did worse than me? What would it be? A -1 here. +1, there's 16% left. What would it be for -1?
Still 16.
16 again. So there's 16% here. So if somebody gets a score of -1, you could say that 16% did worse than that person. If somebody gets a z-score of +1, and you may need to listen to this again, that's okay. If somebody gets a z-score of +1, what percentage of the students did you do better than? That's a little more tricky. A z-score of +1. What would be the logic there? Can you help me out with the logic here? It's a little tricky. It's okay. Z-score of +1. And I said, hey, Mom, I got a Z-score of +1 today. And she said, oh, that's all well and good. How many students did you beat? What percentage of students did you beat?
84.
How did you come up with 84?
If 16% did better than you, then you take that away from 100%, and that's what you have left.
If 16% did better than me, then you could do 100 minus 16 to get to 84. There's even a second way to do this as well. You could say if there's 16% here, how much is left in here between 0 and +1?
Take the 50%, subtract 16.
34, exactly. There's 34 in here, and how much is all the way down there? Below 0.
The other 50.
Another 50. Don't worry about that 16 there. Another 50 there, so you could say, hey, I got a score of +1. I did better than 84% of the population. There's one more kind of magic number. We'll get to the magic number actually, and it'll be the right book here. There's a chart in your book that you get to learn a little bit about. It's in the back once again. It's another table. And this is the table that actually shows all these percentages, per se. Let's see if I can find it. Nice book. There we go. Page 699. Page 699. Page 699 presents the unit normal table. Take a look at the first value in there for the z-score. The top left, what is the first z-score that they give you on 699? What is it?
0.
And what does it tell you is in each tail? In the body, so a z-score of 0, there's 50% basically in each tail. So that's,
Got it.
this table gives you the exact values per se. So a z-score of 0 means there's 50%, as I kind of drew it up here, between this score in the body and this score in the rest. Let's even go to the z-score now of 1. Looks like you have to turn the page. So a z-score of 1, can you find it on the next page? A z-score of 1. What is the actual correct value for what percent did better?
84.13.
Well, if it's how many did better,
Better. 15.87.
it's 15.87%. Can you find it in there? But we round to what? Because we don't need that. 16% are in the tail, did better. And what does it tell you is did worse?
84.
84%. Does it kind of say the 84 in there? So, go ahead.
Yeah.
So z-scores are very useful for us because if you want to know how somebody did, then the best way to figure out how somebody did is to get a z-score, and you can even know not only how somebody did, but what percentage did better or worse. What percentage did better or worse? So we have the last example here. It'll be in the agenda here. It's time to stop this one.